Today we're going to be talking about proving triangles congruent by angle, side angle, and angle, angle, side. So two more ways to prove our triangles are congruent. Our angle, side angle. And again, notice this is a postulate. And remember, we're never going to be using 4.3. We're going to be saying angle, side angle. Where again, it's like we're carving things out. I go angle, side, angle. Angle, side, angle for how we are proving our triangles congruent. So the key thing I have here is the side is included between the two angles. Okay, so you go angle, side, angle. It's like I'm tracing it out. I don't even lift up my pencil. Versus angle, angle, side. Angle, angle, side. Again, it's like tracing it out. Angle, angle, side. I went angle, angle, side. And I have to lift up my pencil. I shouldn't have. I should have. Let me retrace this one. Angle, angle, side. Our side is not included between the two angles, okay? So those are two new ways, and this is a theorem. This is something that we could prove. I'll talk about a proof for it real quick because I love this stuff. Okay, I know two angles in the triangle are congruent. Angle F is congruent to angle C by the third angle theorem. And then I know that these two triangles are congruent because now I have side, angle, side. Okay? Okay. So our ways to prove triangles congruent. This is kind of like a summary for you. We have side, side, side. Side, angle, side. Angle, side, angle. Those are all postulates. And then we have angle, angle, side. There's also one that's specific to right triangles, okay? Hypotenuse, leg. Our book doesn't talk about this, but it's something that's popular that I'm kind of surprised is not in our book. So if you have the hypotenuse and leg of one right triangle, so if I have the hypotenuse and the leg of one right triangle congruent to those same parts in a different triangle, then our triangles are congruent. And this is only true for right triangles. Okay, let's do some problems. State whether the two triangles are congruent. If they are, state how you know. So I have angle, side, angle, angle, side, angle, angle, side, angle. Here, that common side is congruent. This is side, side, side. This has a common leg. So our hypotenuse leg. Vertical angle is congruent. This one is side, angle, side. This one I have vertical angles. That's the only thing I know. Those are not congruent. Here I have vertical angles. I have angle, angle, side. So I think I covered them all with a not congruent piece in there. Let's do some proofs. I love triangle proofs. Congruent triangle proofs. Okay. And this one is using a lot of everything that we know. So let's write down the given. Let's just write down the first part of the given. And let's use that. I'm trying to prove WRL is congruent to EDL. So L is the midpoint of WE. Okay, so write something about your given. I'm going to make that look a little bit more like an E. I didn't like how that looked. Okay, write something about your given. We know that if something's a midpoint, it splits up into two congruent pieces. So this piece here is congruent to that piece there. So I have a WL is congruent to LE, and that's our midpoint theorem. So I have now, let me list them out here. I have at least a side. Okay, let's see what else I know. I'm going to bring in some numbers. Again, you can write in those numbers if you don't want to be listing your angles by 3 letters. So angle 1 and angle 2, hey, those are congruent by vertical angles congruent. So I have an angle in there. And these aren't necessarily in the right order. I have an angle that's congruent. If I had another angle, I could say that these triangles are congruent by angle, angle, side. Or I could use angle, side, angle. We know WR is congruent to DE. So this is a transversal. Technically, both of those other sides are transversals. I'm going to call this an angle 3. I'm going to call this an angle 4. Oh, what's kind of cool about those angles is those are alternate interior angles. So I have WR is parallel to ED. Since I didn't write that at the very beginning, I now have to write it. I write something about that given. The something that I know about that given is angle 3 is congruent to angle 4. Angle 3 congruent to angle 4, well, that's parallel lines, gives me alternate interior angles congruent. Now I have my triangles congruent. So I finally have my last angle. So I just now need to write a correct congruence statement. What's kind of nice is I can just look and copy what's in the need to be proved, so I get my congruence statement correct. But now I need to make sure I have the correct reason. I have here angle, side, angle. Angle, side, angle. So it's angle, angle, side. That's not how I listed them in my proof, and that's okay. Okay, proof number 2. Oh, this one's a good one. So I have angle NKL. So this angle here is congruent to NJM, this angle here. And I have that KL, this segment here, I'm going to kind of highlight it in blue, congruent to JM. I need to prove that JN is congruent to KN. What I'm going to do is I'm going to kind of pull apart those triangles. I'm going to do my best to pull these apart correctly. I have J, N, M, and I have K, L, M, where JM is congruent to KL. Angle J over here is congruent to angle K over here. So how could I get these triangles congruent? Well, first I have to label them correctly so we don't make a mistake. Notice how I haven't even started my proof yet, and I just relabeled it the same way. Let me highlight these triangles. So I have J, M, N here. What's this one? And then I have L, K, N. I have that triangle there. Those are what we call overlapping triangles. It's kind of, it might be a little bit challenging for you to see, but if you break them down, if you break it down into different and draw them out separate, that might help you. I'm trying to prove, I'll draw in black what I'm trying to prove. I'm trying to prove LN is congruent to ML, that these little segments here are equal. Well, if you look at that, those are little segments, I should mark those with 2, in my, once I've pulled those diagrams out, those are little segments in my smaller triangles that I pulled out. So I need to get these triangles congruent. Let's first start by writing out the given. Okay, so in this is an angle, that's this angle here, congruent to that angle there. I have a side. If I could get another angle congruent, I could use angle, angle, side, or angle, side, angle. I don't know anything about L and M, but I do have this common angle N here. That's angle N down here, angle N down here. So angle N is congruent to angle N. By the reflexive property. So now what do I have? I have an angle, I have a side, and I have a third angle. I can say that my triangles are congruent. Triangle JMN is congruent to triangle KLN by angle, angle, side. Again, I'm not listing these in the right order here when I'm listing them out in my proof, and you need to understand that. And that's kind of why, yes, it's a checklist, but don't even write those because you might confuse yourself. Now notice here that MN and LN are corresponding pieces. So LN is congruent to MN by CPCTC. Okay, so those are some good geometry proofs and our additional 3 ways to prove triangles congruent: angle, side, angle, 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 side, and hypotenuse leg. Thanks for watching my video.